Hey there, welcome to the lesson. In this lesson, we shall learn on how to evaluate questions based on applications of differentiation. And without further ado, let's go straight to the questions. Question number 1. The displacement s meters of a moving particle after t seconds is given by s is equals to 2t cubed minus 5t squared plus 4t plus 2. Determine A, the velocity of the particle when t is equals to 2 seconds. Part B, the value of t when the particle is momentarily at rest. Part C, the displacement when the particle is momentarily at rest. Then the last question, the acceleration of the particle when t is equals to 5 seconds. So let's go to the first part of the question. The first part, the velocity, supposed to determine the velocity of the particle when t is equals to 2. So given the displacement and required to get the velocity, this is how we get the velocity. Velocity is obtained by differentiating displacement with respect to t. So velocity will be obtained by differentiating displacement with respect to t. And these will give, when you differentiate this displacement with respect to t, we get 6t squared minus 10t plus 4. So that is the expression for velocity. So velocity when t is equals to 2. So what you're going to do here is just to substitute t with 2. So it will be obtained by velocity 6 2 squared minus 10 2 plus 4. And this gives, when you multiply these, this is what you're supposed to get, give 24 minus 20 plus 4. And working out this 24 plus 4 minus 20, this will give 8 meters per second. So that is how we're supposed to work out the first part of the question. Now the second part of the question, the value of t when the particle is momentarily at rest. So one thing we're required to know is that when the particle is at rest, velocity will be 0. So at rest, velocity will be 0. So in this case, since we have obtained the expression for velocity from the first part of the question, which is 6t squared minus 10t plus 4. So when the particle is momentarily at rest, the value of v is supposed to be 0. So we equate this expression to 0. So 6t squared minus 10t plus 4 is equals to 0. So we work out this. We can simplify this one is a quadratic equation. So we can simplify it. We can divide everything by 2. And this will give 3t squared minus 5t plus 2 is equals to 0. Dividing everything by 2. So working out this, look for two numbers. We can solve this one using factorization method. This product, look for two numbers whose product is 6 and the sum is negative 5. And these numbers are negative 2 and negative 3. So we solve this. So this will give 3t squared minus 3t minus 2t plus 2 is equals to 0. So 3t, this is a t minus 3 minus 1, this will be minus 1 minus 2 t minus 1 is equals to 0. Require more space here. So this gives 3t minus 2 t minus 1 is equals to 0. So therefore 3t minus 2 is equals to 0, and in this case t will be given by 2/3 seconds, or t is equals to t minus 1 is equals to 0, and therefore in this case t is 1 second. So that is how we are required to work out this second part of the question. So we are required to get the value of t when the particle is momentarily at rest, and we have obtained two instances when t is equals to 2/3 seconds and when t is equals to 1 second. Now we can go to the next one, the displacement when the particle is momentarily at rest. The displacement when the particle is momentarily at rest. Now for the second question, we require to get the displacement. So we need to get the expression for displacement, which we given here. 2t cubed is there. So that is the expression that you're going to use. So 2t cubed, let me read it very fast, minus 5t squared plus 40 plus 2. So that is the expression that we are going to use. Now, since we have obtained two instances when the particle will be at rest, so the particle will be at rest at t is equals to 2/3 and when t is equals to 1. So we begin with the first one. So when t is 2/3 seconds, so what is the value of s, which is the displacement? So s, therefore we substitute the value of t in this expression of displacement. So 2/3 cubed minus 5 2/3 squared plus 4 2/3 plus 2. So when we work out that, this is what you're supposed to get. This will give 16. This will give 16 over 27, and then this one will give 20/9. And this one will give 8/3, then plus 2. We need more space here. Need more space, so that is what you get. So working out these using the calculator, 16 divided by 27 minus 20/9 plus 8/3 plus 2, this gives 3 and 1/27. 3 and 1/27 meters. So that is the first instance. So the second instance is when t is equals to 1 second. What is the value of displacement? So s will be given by 1 cubed minus 5. This is 1 squared plus 4, 1 plus 2. Just substituting the value of t in the expression for displacement. So this gives 2 minus 5 plus 4 plus 2. And this will give 8 minus 5, which will be 3 meters. So that is how you're supposed to work out that part C of the question. So we have two values. So we have 3 meters and 3 and 1/27 meters. That is a displacement. The last question is the acceleration of the particle when t is equals to 5. So how do you obtain acceleration? Acceleration is given by when we differentiate velocity with respect to t. That is when we get acceleration. So in this case, since we have the expression for velocity, which is 6t squared minus 10t plus 4. That is expression for velocity. We had obtained that one earlier. It is there. So when we differentiate these, we get the differential function dv over dt with respect to t. This gives acceleration, and this will be 12t minus 10. So that is the value of acceleration. Now we require to get acceleration when t is equals to 5. So we just need to substitute. So acceleration will be given by 12 when t is equals to 5. So this will give 60 minus 10, which is 50 meters per second squared. So that is how we are required to get acceleration in that part. So that is how we're supposed to work out that question. Question number 2. The displacement s meters of a particle moving along a straight line after t seconds is given by this expression: s is equals to 3t plus 5 over 4t squared minus 4t cubed plus 8. Part A of the question: determine the expression for the initial acceleration. Part B, that is B part 1, calculate the time when the particle was momentarily at rest. B part 2, calculate its displacement by the time it comes to rest momentarily. Then part C, calculate the maximum speed attained. So those are the questions we're supposed to solve. So let's go to the first part of the question: determine the expression for the initial acceleration. So what you're supposed to note is that we are given displacement, we are not given velocity, we are not given acceleration. So what you're supposed to do, the first thing, when we are moving from displacement to velocity, we differentiate. When you're moving from velocity to acceleration, we differentiate. So in this question, we are given displacement. So to obtain the expression for acceleration, we shall first differentiate to obtain velocity. That is, we differentiate displacement to obtain velocity. Then after obtaining velocity, we differentiate velocity, and now we get acceleration. So that is what you're going to do. So the first thing, we differentiate distance or displacement with respect to x, with respect to t, that is ds over dt. This will give velocity, and when you differentiate these, this is what we get. We get 3 plus 5 over 2t minus 12t squared. That is what we get. Then after obtaining velocity, we differentiate it again. So v is given by 3 plus 5 over 2t minus 12t squared. We now get dv dt, that is differentiating velocity with respect to t, and this gives acceleration. So differentiate this v, we get 5 over 2 minus 24t, and therefore the expression for acceleration is given by 5 over 2 minus 24t. So that is the first solution. Now we go to part 2 of the question: the time when the particle was momentarily at rest. So one thing we are supposed to note is that when the particle is at rest, velocity is 0. That is very important. When the particle is momentarily at rest, velocity at that time is 0. And therefore, we shall take the expression for velocity, which was here, v is equals to 3. So v is equals to 3 plus 5 over 2t minus 12t squared. So velocity equal to 0. 0 is equals to 3 plus 5 over 2t minus 12t squared. So we need now to reorganize these to form a quadratic equation, and then we solve it. So we multiply everything by 2 to get rid of this denominator. So and reorganize it so that we have negative 24 t squared plus 5t plus 6 is equals to 0. Once again, we get rid of this negative. We multiply every term by negative. We get 24t squared minus 5t minus 6 is equals to 0. Now, when you look at this quadratic equation, when you solve it, we shall get two values of t. And the easiest way to go about this is use of a quadratic formula. So t is given by minus b plus or minus, this is a quadratic formula, b squared minus 4ac, everything divided by 2a. Now in this case, where a will be 24, b will be negative 5, and c is negative 6. So substituting these values in the quadratic formula, we obtain t as negative b will be 5 plus or minus the square root of this. So this b squared will be 25 minus 4 into a, which is 24, times c, which is negative 6. Close the bracket. Then 2 times 4, 2 times 20 is 2 times 24. So this gives 5 plus or minus everything inside the bracket. When you work it out using the calculator, you get that one is 601 divided by 48. So this gives 5 plus or minus square root of 601 is 24.52. Everything divided by 48. So we shall have two values of t. The first value of t will be given by 5 plus 24.52 divided by 48, and these work it out using the calculator. This will give 0.615. Then the second value of t will be 5 minus 24.52 divided by 48, and this gives a negative 0.4067. Now we shall ignore the negative time, since we can't have the negative time. So we shall go with t will therefore be given by 0.615. So we ignore the negative since we cannot have a negative time in this case. Now that is how we're supposed to solve that part. Now let's go to the other part of the question, which is about the displacement by the time it comes to rest momentarily, its displacement. So let's first write the expression for displacement, that is 3t plus 5 over 4 t squared minus 4 t cubed plus 8. So we are required to get the displacement by the time the particle comes to rest momentarily. And in the previous question, we have just identified in this question part B, the time when the particle comes to rest. So we shall use that time, which we have obtained as t as 0.615. So this is the time when the particle comes to rest. So we need now to use the same time to get its displacement when it comes to rest. So to do this, we shall take this expression for displacement and we substitute this value of t, that is when the particle is at rest. So substituting this, we get 3 0.615 plus 5 over 4 0.615 squared minus 4 0.615 cubed plus 8. So that is how you substitute that. Then you simply use the calculator to work out these, and when you work it out, this is what you're supposed to get. You'll get 9.387 meters. So that is the displacement when the particle comes to rest momentarily. Let's go to the last part of the question. The last part of the question is about calculate the maximum speed attained. The maximum speed attained. So to get the maximum speed attained, the first thing we're required to note is that in this case, the speed is the velocity. Then another thing very important to note is that at maximum speed, acceleration is 0. At maximum speed, acceleration is 0. And therefore, we shall take the expression for acceleration, which we got in the first part of the question, which is here. Acceleration is given by 5 over 2 minus 24t. So that is the expression you're going to take. So acceleration is given by 5 over 2 minus 24t. So at maximum speed, this is supposed to be 0. So working out this, you get 24t is equals to 5 over 2. So t, therefore, will be given by 5 over 48. So this is the time when it attains the maximum speed. That is the time when it attains the maximum speed. That is 5 over 48 seconds. Now the speed when it attains maximum speed is given by when we take the expression for velocity and then we substitute this value of t. So expression for velocity is this is 3 plus 5 over 2 t minus 12t squared. So when t is 5 over 48, that is when it attains the maximum speed, what will be the speed? So we simply need to substitute this 3 plus 5 over 2 within 5 over 48 minus 12 5 over 48 squared. So this is the expression we need to substitute, and then we get the speed. Therefore, when you work out this, it's supposed to give 3.13 meters per second, and that is the maximum speed attained. So that is how you're supposed to work out that question. Question number 3. The distance s meters from a fixed point covered by a particle after t seconds is given by s is equals to t cubed minus 6t squared plus 9t plus 5. Calculate A, the gradient to the curve at t is equals to 0.5 seconds. B, determine the values of s at the maximum and minimum turning points of the curve. Then part C, which is the last one, on the space provided, sketch the curve of s is equals to t cubed minus 6t squared plus 9t plus 5. So let's go to the first part of the question. We're supposed to get the gradient to the curve at t is equals to 0.5. So to get the gradient of the curve at that point, we shall take the expression for distance and differentiate. So gradient will be given by, when you take this expression, you differentiate distance with respect to t, and this will give 3t squared minus 12t plus 9. So that is the expression for the gradient. Now at t is equals to 0.5 seconds, what we're going to do here is just to substitute. So 3t is 0.5 squared minus 12, 0.5 plus 9. So that is how we're supposed to get the gradient to the curve at t is equals to 0.5. Differentiating to get the gradient, then substituting that value of t, which is 0.5. And when you do this is what you're going to get. This will give 0.75 minus 6 plus 9. Therefore, when you work out this, the gradient will give 3.75. 3.75. That will be the gradient. Now the second part of the question, determine the values of s at maximum and minimum turning points of the curve. So to get the values of s at the maximum and minimum turning points of the curve, there is something we need to get first about this turning points. So at turning points of the curve, the gradient will be 0, and the gradient in this case is what we have obtained there, ds over dt will be 0. And since we have got the gradient, just you take that gradient, which is 3t squared minus 12t plus 9 plus 9. So at turning point, this value of gradient is supposed to be 0. So we need now to get the values of t at the turning points. And when you look at these equation, these are quadratic equation. When we work it out, we shall obtain two values of t. So we work out these. We can simplify this by dividing everything by 3 to get t squared minus 4t plus 3 is equals to 0. Now working out these, this is what you're going to get. You factorize, you look for two numbers, which will give the product is 3 and the sum will give negative 4. So these will be negative 3 and negative 1. So we give t squared negative t negative 3t plus 3 is equals to 0. So t factorize minus 3 t minus 1 is equals to 0, and therefore t minus 3 t minus 1 is equals to 0. So you get two values of t in this case. So there will be two values of t. So these values are t minus 3 is equals to 0. So in this one you get t is 3, or t minus 1 is equals to 0. Here t will be 1. So you obtain the values of t, and we've got the values of t as 1 second and 3 seconds. Now we need now to go ahead and get the values of s. We have not finished. We get the values of s. So let me create more space here. So now, since we obtained two instances, two values of t, we need now to answer the question and get the values of s at this turning point. So at turning point, this is what you obtained. At turning point, the values of t will be 3 and 1. So what is the value of s? What is s when t is equals to 3 and t is equals to 1? So we start with the first one. When t, we're going to start with when t is equals to 1. So the expression for s, remember it is here. It is given t cubed. So the expression for s, this is t cubed minus 6t squared plus 9t plus 5. Just confirm this. Yeah, it is there. So when t is equals to 1, here to 1 cubed minus 6, 1 squared, we just substitute, and this gives 1 minus 6 plus 9 plus 5. Therefore, this will give 9 meters. Give 9 meters. Now we should go to the second. Let me create more space here. So that is the first one. So what about when t is equals to 3? When t is equals to 3. So when t is equals to 3, we just need to do the same thing. So s, we substitute the expression for s, which is 3 cubed minus 6 3 squared plus 9 plus 5. So this gives 27 minus 54 plus 27 plus 5, and when you work out these, you're supposed to get 5 meters. So that is what you get, 5 meters. So now we have answered the question. Since we are required to obtain the values of s at maximum and minimum turning point, so we started by getting the values of t at the turning point. We got the values of t as 3 and 1. Then we use the values of t to get the values of s when t is equals to 3 and when t is equals to 1. And we have got the values of s. Now the last one is on the space provided. Sketch the value, the curve of s is equals to t cubed minus 6t squared plus 9t plus 5. Now when sketching that curve, we require to obtain the stationary point. We need the stationary point. So stationary point. This is very important to enable us get that, and the stationary point will be obtained from this previous question. When t was 1, s was 9. So that will be the first stationary point. When t was 1, y was 9. That is s. So 1, 9. We are going to use that to plot. And the other stationary point when t was 3, the value of S was 5. So these are very important. Then those are the stationary points, or in short you can call them the turning points. Those are the turning points of the curve, of the stationary points. Now from there we need to sketch, to have a sketch of how that curve will look like. And to sketch we will need to use the values of t at the stationary, or the turning point. So at turning points, t was 1 and t is 3. So when t is equals to 1, we need to sketch these. So x, then the differential function, which is ds over dt. So we prepare this small table here. So when t is 1, of course we got this one, the differential function is supposed to be 0, the gradient is 0. We pick another point to the left of 1, which is 0, and another point to the right of 1, which is 2. Remember to get ds dt, that is the gradient, and the gradient is here. The gradient function is here, ds dt. So this is the gradient, 3t squared. So let me just put it here, that ds, we get this, ds dt is equals to 3t squared. We get it 3t squared minus 12t plus 9, minus 12t plus 9. So this is what we're using to fill this, to get the value of the gradient. So when x is 0, or when t is 0, this remember is the same as t. So when t is 0, these are the value of the gradient at that point will be 9. Then when it is 2, you get that one will be negative 3. So when you sketch that curve, you realize it will be like this. This is positive, then 0, then negative. So that is how the curve will look like. So this one is 0, this one is positive, this one is 0. So this is a maximum point. This one is a maximum point. That is how the first one. Now the other value you're going to use is when t is equals to 3. So we do the same thing. So which is a t, then ds over dt. So we just pick a value. This is a 3, at that point is 0. We pick a value to the right of 3, can pick 4, 1 to the left, which is 2. So when you get the gradient, and the gradient function is here, this is what you're using. You get, when t is equals to 2, then this will be negative 3, and then when t is equals to 4, it will be 9. So when you sketch this kind of a curve, this is how it looks like. So this side is negative, so that is negative. Then we have 0. We rub this straight line, so that is 0, and then this is positive. I think I need to draw a better one. We draw a better one. So that is like that. That is negative, then 0, then positive. So this one is a minimum. So this one is a minimum point. No, not the other one is maximum point. This one is a maximum point, where we have, it is moving from positive to 0, then negative, and then this one is moving from negative through 0 to positive, so is a minimum point. Now, having obtained that, we can now proceed and draw. We can now proceed and sketch that curve. And this is how you're going to do it. We're going to use the stationary point and also another 2 points. So to sketch these, we get these. Now, having so this is y, that is the y-axis, and then this one is the x-axis. This is 0. So when t is 0, we down here. So when t is 0, s will be given. So this one is t. This is the value of s. So s will be 5. So we can put 5 somewhere here. That is 5. Then we need to use the stationary points. The stationary points are here. The 2 stationary points, 1 and 9. So when t is 1, so we need to use also these. So 1, this point, 1, 9. So we can put maybe 1 is there. And then 9, can put 9 to be somewhere there. We are just sketching, so that will be the other point. And then the other point is 3. The other point is the station 3, 5. The stationary point is 3, 5. So 3, 5. So 3 is somewhere. You can put it somewhere there. So 3, 5. That is the other point. So those are the points that we need to use. Those ones will give us a sketch. And since we have obtained that at 1, when t is equals to 1, we have a maximum point, and when t is equals to 3, we have a minimum point. So in sketching the curve, therefore, this is what you're going to do. So this curve will look something like this. So that is how the curve will look like. Since we draw it again, so it will look something like this. Yeah, that one is better. So that is just a simple sketch, where this one is the max at 1. Here we have the maximum point, and at this point we have a minimum point. So it is forming an n at maximum and then a u at the minimum point. And you can see this from the sketch. So when x is 1, we have a maximum point. You can see that from the sketch. Then when when t is equals to 3, you can see that one is a minimum point. It is dipping downwards. So that is a simple sketch. The other point we have used is when t is equals to 0. And for this one, we have used the expression form. When t, just use, here we have use s, the expression for displacement, which is given by, we had obtained that one, it is there in the question. So that one will be s is here, t cubed minus 6t squared, t cubed minus 6t squared, t cubed minus 6t squared plus 9t plus 5. plus 9t plus 5 plus 9t plus 5. So when t is 0, we have found s is equals to 5. That is where you have obtained this value here, 0, 5. And then for the other 3 points, 2 points, we have used the stationary points, and you have been able to obtain our curve. So that is how you're supposed to sketch the curve given the function. Question number 4. A particle moves on a straight line such that its displacement s meters from a given point is given by s is equals to t cubed minus 5t squared plus 3t plus 4, where t is time in seconds. Find a the displacement of the particle at t is equals to 5. So for this part, we just need to get the expression for displacement, which is s is equals to t cubed minus 5t squared plus 3t plus 4, and then we substitute what is the displacement when the particle is at t is equals to 5. So when t is equals to 5, just substituting, so 5 cubed minus 5 plus 3, 5 plus 4. And this gives 125 minus 125 plus 15 plus 4. These will give, working out this one using a calculator, this will give 19 meters. So the displacement is given by 19 meters. So in that part, we just needed to take the expression for displacement and substituting that one with the time is equals to 5 seconds. Now the second part of the question is the velocity of the particle when t is equals to 5. Now to obtain velocity is obtained by differentiating displacement with respect to t. So we take this expression for displacement s, we differentiate it, it gives velocity, the expression for velocity. So when we differentiate that, it gives 3t squared minus 10t plus 3. So that is how you're getting it. Then we need now to get the velocity. Now since we have the expression for velocity as 3t squared minus 10 plus 3, when t is equals to 5, we just need to substitute 3, 5 squared minus 10, 5 plus 3. These will give is 25 times 3, which will give 75 minus 50 plus 3. And these, when you work it out, will give 28 meters per second. So that is the velocity. The next one is the values of t when the particle is momentarily at rest. We've just worked out that in the previous question, and we said that the particle is at rest when velocity is 0. That is when the particle is at rest, when velocity is 0. So we need to take this expression for velocity and equate it to 0. So 3t squared minus 10t plus 3 is equals to 0. So we get the value of t. This is a quadratic equation. You get two values of t. So get two numbers whose product is 9 and sum is -10. And when you work out these numbers would be, product is -1 and -9. I think that is okay. So we have 3t squared and negative t plus -t minus 9t plus 3 is equals to 0. So factor out 3t is common, so t minus 1 minus 3, then this will be this would be 3t. May get this properly. So this is negative, oh I'm sorry, something is wrong here. So t is common in this, so that you get, this will give 3t minus 1, so that this one gives 3t minus 1. I think that is correct now. So having got that, you get either t minus 3 and 3t minus 1 is equals to 0. We get more space here. So t minus 3 is equals to 0. So t will be 3, or 3t minus 1 is equals to 0. So in this case, t is equals to a third. So those are the two values of t. T is equals to 3 seconds and t is equals to 1/3 seconds. So those are the values of t when the particle is momentarily at rest. So one thing we're not supposed to forget is that when the particle is at rest, a velocity is 0. The last one is acceleration of the particle when t is equals to 2. Now to obtain acceleration, we differentiate velocity with respect to t. So take the expression for velocity, we differentiate that, it gives acceleration. So we differentiate these, it gives 6t minus 10. So that is what you get after differentiating the expression for velocity. It gives acceleration. So acceleration is given by 6t minus 10. So when t is equals to 2, just substitute minus 10, and this gives 12 minus 10, and you get 2 meters per second squared. So that is how you're supposed to work out the last part of the question.